everyone. It's kind of small class, but this class was kind of created very last minute. I've got Tuesday and Thursday are kind of time slots I put for you lot if you can make it. And I've also got my other stats class that you can drop into those ones. Really what this does is it gives me an opportunity to, to go over any problems that you might have as you're going through the homework or a concept that's not making sense. Because it's quite difficult to learn any subject on our own, especially you now have to do it online and on your own. So I'm here as a kind of resource. So when we have these meetings, you can say, can we go over this question or can we talk about that? And I can do that as well. And the second thing I want to do in this is to make it a bit more like a lesson. So I'm going to go over as many topics that we need to cover so that you've got a good foundation and hopefully your homework will be easy to do as well. Just got one or two more people coming in, and then I'll get started. Right, now one of you has got a code that doesn't make any sense to me, so whoever you are, BRIFR, could you tell me who you are, because that's really not a very pronounceable name. Don't know if you can hear me yet. No, I don't know who you are. If I don't know who you are, I'm going to kick you off the site. So you better, thank you, and I know who you are. Really. Okay, so get introductions over with. My name is Donald Robertson. I'm going to be your professor for Introductory to Stats. It's a terminal math class, which means there are no other math classes after this. If you want to do other math classes, you have to go and do the pre-calculus 141 and so on. Typical kind of people who take this are for your medical reasons. You're going to be a nurse, you're going to have something in the medical field, and statistics is very important for those people because a lot of the information as you go through your career will involve them telling you new ideas, new treatments, whatever it might be, and that is provided in a very statistical format, so you have to understand how to read the information, how to make sense of it. And the others are taking it because it's a math requirement, and if they do this, they are finished. So let me tell you that most of what you need to know is online. If you look at your Canvas site, we've got everything there. The syllabus is there. You also will find how to join WebAssign, and obviously since you're here, you know how to join Zoom. And WebAssign is very important for this class because that's where all your homework and all your exams are going to be. So if you haven't even signed up for WebAssign yet or started looking at it, you really should. The course is broken into 2-week chunks mostly. And so you're going to have 2 weeks in which to do chapters 1 and 2. And the assignments are online in WebAssign, what questions you need to do. And then week 3 and 4, you get some more stuff to do. Week 5, you get some. And then you have a midterm. And that midterm will be online as well. And that will be in WebAssign. And then you have 2 weeks, and then your final, well, 1 more week, and then it'll be a final exam. So there is a lot of things happening on WebAssign. Your ebook is there, so you don't need to buy a textbook, but you do need to buy access instead to WebAssign. So that means you're going to have to pay to go in. The first 2 weeks you get a grace period, so if your financial aid hasn't came through, still sign up for WebAssign. They'll give you 2 weeks where you can take part and have no problems with it. At the end of that 2 weeks, they are going to come back and say you better pay or we'll drop you. So you need to get that sorted out. I hope financial aid is better to you this year than they were during the summer. I've been told that they've got a lot of the glitches out of CTC Link that was causing that, because it wasn't really their fault. And so hopefully if you're on a financial aid situation, you've got a couple of weeks to get your money, so you'll be able to pay for the WebAssign. If anybody wants to share, I don't need the details in numbers or anything, but is financial aid working? Are you getting letters and whatever you get saying your money's on the way kind of thing? Or are you still in a queue just waiting for something to happen? Does anybody share that with us? I've got a horrible feeling I'm talking to myself right now. It can't be. I can see some names. I guess no one wants to share the fact they get financial aid.
What was the question?
I was just asking, is financial aid working? Are you getting letters right now from financial aid saying your money's on the way?
I don't know. I don't think so.
Do you get financial? Oh God, forget that. I'm asking too many personal questions. What I was hoping to get is somebody says, I get financial aid, and I got a letter saying it'll be due in, October the 7th or something. Because in the summer, some people didn't get any of their money until virtually the end of the quarter, which is ridiculous because you obviously need the money before then. But I digress. Okay, so let's say get WebAssign up and running. You only have 2 weeks to do the first 2 chapters. If you don't do them at the end of the 2 weeks, they are gone. And that means you've lost a big chunk of points that you won't be able to get back. So don't procrastinate. You've got this week, what's left of it, and next week. And the homework is due on Sunday, midnight, October the 4th. So that's the last day it can be done. Yeah. Has anybody got any questions about WebAssign before I move on? Okay.
Yeah, is there, or actually I have a question.
Mm-hmm.
Is there a like section where we can look, have they written out like details of how the exam is going to go, like how to find it and how they're going to load it and like?
Oh, okay, right. If you've never done WebAssign before, what's going to happen on the day of the final, right? And it's in the syllabus. It's a Monday, whatever it is, or a Tuesday, whatever it is. I can't remember off the top of my head. Let's say it's a Monday. When you turn up to WebAssign, you'll have to log on to Zoom so I can see you. And the test will appear in WebAssign. And once it appears, you'll have 3 hours to do it. It's a midterm exam. And then at the end of that 3 hours, it stops. And whatever you've done, it's finished. And then what you need to do is, if you wish to get extra points because partial credit is very important in exams, you will take a copy using your camera, and you will send it to me, the working, as a PDF, and I will go through that working and I will adjust your grade according to any extra partial credit I can give. So if you get a question wrong, the software is just going to say 0 out of 10. If I see the working for it and it's 3/4 right, you might get 7 out of 10. So the final and the midterm appear on WebAssign. So you don't need to download it or anything. You just go into WebAssign and it's there, and you click on it and you start the test. And it's basically got questions, and there's a box where you type in your answer, and then another question, you do the same. So that's kind of how it works. When we get closer to the time, I'll send you a PDF with a little bit more detail on what you are expected to do. But that's the gist of what's going to happen.
Okay, thank you.
Okay. Any other questions? Okay, so introduction to statistics. Let's do the big picture. What is statistics? Well, Statistics is studying of data. And it's basically a branch of math that looks at information. That's what data is. In particular, we look at how to collect that data, how to summarize it, how to make predictions using the data, and how to test for evidence using the data. Now, pretty much I can't think of anybody who hasn't been exposed to information that statisticians are provided. If you go on the television and you watch any kind of news program or business program or some program along those lines, you're going to find that at least now and then they're going to say things like, the latest poll has Kentucky 2% in favour of Joe Biden rather than President Trump. You might hear data that says the latest statistics says that the death rate, if you catch COVID, is 0.5%. Those kinds of things are statistics. Those are information that has been collected and reduced to essentially numbers. And those numbers are now telling us a little bit about the reality of who's likely to win Kentucky in the election and what's your chances of dying if you catch COVID, for instance. Most of this data, if it's done well, is very useful. And if this data is collected badly or isn't analysed in the proper way it should be, then it can be very misleading. And unfortunately, when politicians are involved, there is a very big temptation for them to do exactly that. So you have to be skeptical of information that's given to you without you being given the whole picture. So I like to create a pretend story to give you an idea of how that would work. So let's pretend that in Seattle, a politician goes on the radio or the TV with a big headline and he says that Seattle is racist against Scottish people. They don't like Scottish people. And the evidence that, the particular evidence that he's using is that only 2% of Seattle's police force are Scottish. See how biased they are? See how racist they are? They don't like Scots people. The police force has only got 2%. 2%, that's all. How nasty those Seattle society is. Is that evidence that Scottish people are being picked on in the police force at least? What other information would I need before I could make sense of that one piece of information? Because there's something vital missing. Anyone? What's missing?
Maybe the percentage of how many are discriminated against?
Interesting. It's not what I was thinking about, but interesting. How about this? Suppose 10% of people who live in Seattle are Scottish. 2% of the police force are Scottish. 10% of the people who live in Seattle are Scottish. I think that is evidence that there is a bias there, isn't there? I mean, if 10% of Seattle was Scottish, wouldn't you expect 10% of the police to be Scottish, and 10% of the teachers to be Scottish, and 10% of the bus drivers to be Scottish, and any other profession, doctors, whatever you want? Wouldn't you expect roughly about 10%, because that's the percentage of the entire population? Would that make sense, that you'd expect that number? And since this is not that number, that would be evidence, wouldn't it? That'd be better evidence. Suppose it was this. Suppose only 1% of the people in Seattle are Scottish. 2% of the police force are Scottish. What is actually that evidence of? Aren't Scottish people being treated better than the general population? Aren't there twice as many policemen in Seattle who are Scottish based on the population size? There shouldn't be that many. Wasn't there a time in American history when places like Boston, it was almost all Irish? If you were a policeman and you were in Boston, you were Irish. Wasn't that an example of, I guess you'd call that reverse bias? Well, it's still bias, where you have a group who are overrepresented rather than underrepresented. So what I'm trying to get to in this story is that when someone tells you something, try and think, is there any other information that I would like to know before I will make that conclusion that the Seattle Police Force are in some way not fair in their choice of picking Scottish people to be in their police force? So that's the gist of how statistics can be used badly, or in some respects, it can be used well. Any questions? Okay, I'm going to start by telling you a lot of jokes, because if I don't get some kind of life out of you lot, we're going to have a long 2 hours. So are you ready for a really corny joke? Because I'm good at corny jokes.
Yes.
Good. Gary Young, are you ready? I guess our baby might be needing some help right now. Okay, here goes. Do you know that I cut down 5,000 trees in my entire career? And I know it's 5,000 because I kept a log.
Oh my gosh.
Pretty bad, Mason?
It took me a minute, but I think it was pretty good. It was pretty good.
Okay. We'll try a second one then, right? So if you don't start answering, guys, you're going to get bombarded with jokes. So you've got to figure this out. Jokes are painful. I better ask some questions and answer some questions, right? So here's number 2. Why should you never play poker in a forest?
Why?
Because there's too many cheetahs.
Oh.
We're getting there, right? One last one. You ready? Okay, here goes. What should you do with a very sick chemist?
What?
Well, if you can't cure him, bury him.
That was a good one.
Okay. Right. See, so I'm okay, right? You can ask me questions and you can certainly answer questions, and I probably won't laugh at you many times, right? So you're in a safe environment here. So let's look at some notes, get ourselves kind of into the swing of things. Pretty much these notes are ones similar to it are on the Canvas site. Okay, are you looking at Math 146 introduction? Is that the page you can now see?
Yeah, I can
Good.
see it.
Good. See, that's what I want. I want yes and no's and thumbs ups. So it basically goes into, just as I said, it's really collection of data, which is what information is. And our job is to organize it, summarize it, and so forth. So data is broken into two major categories. Qualitative data, sometimes called categorical. That's when the information that you collect isn't numbers, it's things like you ask a lot of people, 1,000 people, what's their favorite color? Well, the answer you get back is a yellow, red, green, blue, right? Can you see that the answer, the data is just words that in this case happen to be numbers? Maybe you ask people what countries in the world they've ever visited. So can you imagine they might say Mexico and France and Britain and so forth. That kind of data is called qualitative data. It's information, but it's not numbers, essentially. So the other kind is called quantitative data. It's a bit of a mouthful. The way I remember the difference is quantitative makes me think of quantity, and that means numbers. Right? There's a quantity of things that tends to make me think numbers. So quantitative data would be when you went out and collected the ages of 100 OC students, or the heights of everybody who lived in your street, or the salaries of everyone who worked in a company, right? So the answers you get back there would be, 42 inches, 63 inches, 43 years old, 82,000. You'd get numbers back. And when you get numbers back, the answer is typically quantitative. And what you can do, the way you can analyze quantitative data, because it is numbers, and the way that you can deal with qualitative data, because it's just things like, red, blue, green, are quite different. We won't spend nearly as much time on qualitative data because there's not an awful lot you can do with it once you've collected it. You can summarize it a little bit, and that basically just means find out how many people said red. There's 42 said red, 22 said green, 14 said blue, right? You can categorize it by just, bringing it together into little categories. That's why it's sometimes called categorical data. And then you can draw little pictures that you probably did when you were 10 years old called bar charts. Remember those things called bar charts? Little rectangles. Rectangle for how many said green, another different height rectangle for those who said red. And you could probably answer very simple questions like, 30% of the people picked red and only 2% picked yellow. So you can give the answer as a percentage of the total sample. On the other hand, if it's numbers like quantitative data, you can do all sorts of cool stuff, some of which I'm sure you've heard of before. Can't you do things like calculate their mean? You would probably call that average, So if you had 20 people, couldn't you find their average height or their average weight? You could find what's called the median, which is another measure of what the average typical person is. You can get numbers if you've ever done things in chemistry. You can get a number called standard deviation from data. And that number just essentially tells you how spread out your data is, whether all the numbers are very close to each other or whether they're all over the place. So quantitative data is where we spend almost all of our constructive time. There are tons and tons of examples of quantitative data being used and not so many of qualitative. So that's here's pretty clear cut. Unfortunately, it's not really. Most of it is, but it's not totally. I'll give you an example of some numbers, some data that are numbers, but they don't count as quantitative. And you might think, how does that work? Sometimes things are codes. You use a number, but it's really just a code. So have you ever been given one of those questionnaires, maybe do it online, or maybe you've done it because the college asks you, and they give you a statement, and number one is, you totally disagree, kind of 3 is the middle of the road, and question 5 at the other side is I totally agree. So it might say, do you think the college is efficient in sending out your financial aid? And you give them a scale from 1 to 5. Right, the answer that comes back is a number like 4, but all 4 is a code for, yeah, I agree, you're doing pretty good. A 5 is you're doing brilliant. A 1 is I'm still waiting for my money, you're doing a terrible job. Another example of a code, which is really considered qualitative data, it's not a quantity at all, would be things like, suppose, because I felt like it, I would go to a Seahawks game and I found the numbers that all the players who took part in that game at any point, I got all the numbers and I wrote them down in a big list. So there's number 42, right? There's player 17, whatever else. If I took those numbers, and they are numbers, if I found the average of them, would it make any sense to say that the average number on a player's back was 17.8? Do you see that that average has no meaning? That is a good test that you should use if you're unsure, is it really a code or is it a true number? How about if I got all your telephone numbers and wrote them down in a list, and then I added them up and divided by 6 and said the average telephone number is 123,789? Would that average mean anything? No, right? It has no meaning. That's because telephone numbers are codes. And aren't your social security number just a code? In fact, back home in Britain, we have social security numbers. We don't call them that. We call them national insurance numbers, but they do the same job. But our national insurance numbers have letters in them as well as numbers. And they function the same way. So yeah, if it's a number, it's probably quantitative. If it's not a number, it's definitely qualitative. But there is a kind of grey area. Some numbers aren't really numbers, they're just codes, in which case they belong in that there. Why is that important? You're going to get a homework question, and it's going to give you a piece of data, and it's going to say, we collected data on the age of 200 students. Is it qualitative or quantitative? Right, the age of 200 students, what would that qualify as? So this is a question that you answer. So I'll say the question again, in case you missed it. You collected the ages of, say, 20 students. Is that qualitative or quantitative data? The ages of 20 students.
Is that quantitative?
Yes.
Okay.
I wasn't trying to trick you. The questions very often are that. Suppose you went and collected their surnames. So they'd be Hart and Robertson and Smith and Jones. That's the kind of things that you would get. Quantitative or qualitative?
Qualitative?
Right. How do you tell the difference? Isn't one numbers and the other isn't, mostly? None of those were codes, so I wasn't trying to catch you with one that was a code. I wasn't trying to be sneaky that way. Right. So that's the first major grouping. Now, let's skip on, and then we'll come back to the fact that within qualitative and quantitative data, there are two subgroups, and they are here. I'm going to do it on my white screen, that way I can write down things. So we have qualitative And we know that the other thing is called quantitative. It's a hard one to say, it is for me at least. There are two versions of qualitative. They are called nominal and ordinal. What we're really doing here is building up a vocabulary of words that are used in statistics, so that when you read about someone who did a survey or a study, you might read that they did a study and the data was quantitative and it was this and then it was that, and they go through a whole set of jargon words that you have to say, what does that mean when they use this word? So now you know qualitative. So what's the difference between nominal and ordinal? Nominal is when the data that you collect isn't numbers, right? It's just not numbers. But on top of that, there is no particular order. Would you agree red, blue, green, red? Apart from alphabetical, forget that one. There isn't really any order that makes sense. There's no structure to it. On the other hand, if you had things like I think I might have got these wrong way around, actually. But I'll wait till I finish doing it and you can tell me if I did. Suppose you went to high school and you said to them, which are you? Sophomore, freshman, junior, or senior? Does freshman come before sophomore? I'm not an American, so I can't remember what your school system does. Is that the right order?
No,
Freshman
first.
comes before sophomore.
Okay. Now, the fact that you said that, doesn't that mean that this is a normal order? Isn't there a kind of natural order when you probably do freshman, sophomore, junior, senior, right? It's still not a number, but doesn't it have a natural order to it? And if it has a natural order, it's called ordinal. I remember ord to remind me order, right? That's how I kind of remember. Order, there's a kind of order to the thing. Do you know that one I went and gave you where you might say things like, what's your opinion of something? And at one extreme, I'm paraphrasing it, I hate it, and then sort of hate it, don't care, sort of like it, and then really like it. Imagine you ask someone, what's your opinion of bananas? I hate them. Sort of I hate them. I don't care. Kind of like them, really like them. Do you see in that particular situation, could your answer be one of these 5 phrases? So it counts as quantitative, but doesn't it also have a natural order to it? In fact, in these kind of questions, they normally say, I've done this, I think last week I did this. I was talking to my bank about some question and they give you a little list and they say, on a scale from 1 to 5, whereas 1 they did a really good job to 5 they did a terrible job, whatever way they phrase it, how would you describe the person that you were talking to and how they did their job? And you gave a scale of 1 to 5. Can you see that still counts as ordinal because it's really just a code for these words, right? These phrases. So nominal, ordinal, right? So I'm going to give you a couple of examples and you're going to have a guess. And if you get it wrong, we'll all laugh at you. But if you get it right, we'll all cheer. No, we won't. I'm just pulling your leg. Right, so here's the first one. You go out and you find what countries people have been to. So you ask 200 people and you get a list of countries that they've been to. That's definitely qualitative. Is it nominal or ordinal?
Nominal?
Yes. Would you agree, forget alphabetical, everything can be put in alphabetical order, right? So we don't count that one. With the exception of alphabetical, there's probably not a normal, obvious order to a country, right? Does France come before Germany? Is India in the middle of the two? Should it come first? Should it come last? You see, there's no natural order. That's called nominal, right? How about this one then? The ranks of people in the army, right? So you could be a private, you could be a sergeant, you could be a lieutenant, you could be a general, right? That kind of thing. The ranks of people in the army.
Ordinal?
Can you see the difference?
Yes.
Isn't there a kind of private should go first and, you know, 5-star general, or just call it a general at the end? Isn't there a kind of natural order to that? Even although all you're collecting is, I'm a sergeant, I'm a private, I'm a lieutenant, I'm a colonel, right? The answer is a word, right? That makes it qualitative. But isn't the thing that you're collecting got a natural order to it? Right, am I getting that idea that even although both things are just, they're not numbers, right? They're non-numerical. If it has an order, ordinal. If there's no natural order to it, nominal. This is a harder question, so if you don't get an answer, I can understand it, but it'd be nice if you could think of one. Can you think of another example of some data that would be nominal? No ideas? That's probably an unfair question. Off the top of my head, how about you go and ask 200 people what TV programs they watch, or what sports they like, or what hobbies they've got? You know those kind of questions where they say fishing, or American football, or, you know, sci-fi movies or whatever. Moving on then. Quantitative has two groups as well. In quantitative, the numbers are interval numbers, or they are ratio. Me personally, I think the difference between ordinal and nominal are pretty easy to separate the two. They're kind of, you know, a big gap between each. In these two, the gap is much greater, right? The distinguishing features are quite different, because it's hard sometimes until you get used to it to be able to tell the difference. They're all numbers. For instance, people's height, their weight, the temperatures over a month, they're all numbers. But interval only has numbers where if you find the difference, it makes sense, but the ratio is not true. What in the heck does he mean by the ratio is not true? Give you an example. If I said to you that the temperature was 10 degrees Celsius in one place, and it was 30 degrees Celsius in a second place, some people, even although they think it makes sense, would say that this place is 3 times hotter than the other place. That's a ratio. Whenever you take something and divide it by something else, in this case 30 divided by 10 gets you 3, they would say that place here, right, is 3 times hotter than this place. And they're doing it because the numbers are certainly 3 times the other. But that piece of information is not actually true. Do you know if you take these same two temperatures and you turn them into Fahrenheit, so it's the same temperature, it's just using different units. If you turn them into Fahrenheit, I don't know what they are off the top of my head, but can we pretend this is 22 degrees Fahrenheit and this is 82 degrees Fahrenheit. Can you trust me that if you turn them into Fahrenheit, the second one isn't 3 times the first one anymore? So it's not the case then that the ratios are true. In other words, if you take one number and divide it by the other, does that answer actually make sense? And temperatures aren't true in the ratio test. That's why temperatures are interval. So what would be ratio? Well, how about your height? If somebody is 60, it's a bit hard to do height that way. If something, how about that? If something is 12 inches tall and the other thing is 24 inches tall, wouldn't it be true to say that that's twice as tall as that? Now, if you turn 12 inches into feet, isn't the first thing 1 foot and the second thing is 2 foot? Isn't it still 2 times taller? Do you see, it didn't matter what units I used. The information was still valid, right? It's still the same ratio. Do you know if I turned these two guys into centimeters, do you know that this guy would still be twice as big as that one? That's an example of what are called ratio numbers. So temperatures are not, so they're called interval, whereas height is. So a list of things that do work in both cases. So here's a kind of list I'll make up. Let's see what we got. How about some ratios? Well, if you measure the height of people, it will be a ratio. If you find out how much money someone's got, right? If you've got $20 and I've got $10, don't I have twice as much money as you? See, if we turn that money into pennies, don't I still have the same amount of money as you? See, if we went to a bank and turned them into francs and we both walked out, wouldn't I still have twice as many francs as you? Do you see how the ratio doesn't care what units are? So money, height, weight, they're all examples of ratio. Interval, not so common. Temperature, like in degrees Fahrenheit. Time. Now what I mean by time is the time on a clock. Right, let's do the two-thing test. If it's 1 p.m. and then later on it's 2 p.m., does it make sense to say 2 p.m. is twice as long as 1 p.m.? You see, that doesn't make sense. It's not a sensible thing to say. Agreed? Now, what about time passing? Suppose I said it took me 50 seconds to do a lap, and it took this other guy 100 seconds to do a lap. Did this person take twice as long to do the lap of the track as me? Yes. If I turned those times into minutes or weird decimals, the answer would still be yes. So time on a clock, like 4 o'clock, 3:30 p.m. is interval. But time as in how many seconds something took or how many minutes something took, that kind of time is counted as a ratio. Okay, any questions about just basically the two types of data that you can have? That's qualitative and quantitative, and then the two subgroups for each. Do you feel comfortable with that? Last chance.
Yeah, I just need a few more seconds to finish writing it down.
Okay, what we're doing right now is videoing this. And so when you go to your Canvas site tomorrow, you'll be able to get this video. So if there's anything that's really, I've written an awful lot and you're frantically trying to write it, you could probably just leave it and then, you know, when you've got plenty of time just to peruse it, you could just watch the video and it'll still have this and it'll still be there for you. Plus it'll have the added benefit or distraction of me talking. Are we good with this?
Yep.
Okay, now I'm going to go and show you what the homework looks like and what your site looks like, because in this very short period of time, I'm not too sure what you've been able to do yet, you know, what you've been able to go to. So I'll start with the Canvas site if I can. Okay, go to dashboard, and this should be our class. Okay, looks good. Put that over there. Do you know why I talk to myself?
Why?
It's the only way to get an intelligent conversation. Oh, come on, that's a good one. Okay.
No, that was a good one. I was laughing, but my
You were
was on
laughing
mute.
on the inside, not on the outside.
I
Okay.
was.
I'll take it.
Laugh too.
You were laughing, good. You're going to have to get used to me. I don't know if you've ever had me before. I know Gary Young has, so she's kind of used to what I'm like. I like to have fun, and I like to have participation. So here we go. Hopefully you are looking right now. Is it still in front of you? Are you looking at it now? This is our Canvas webpage. You can say yes or no, please.
Yes.
Okay, we're good. So when you go to this, you will find all this good stuff. And if you click on, I don't know what you're going to see and what you're not. And I'll just tell you what you're going to see if it disappears. If you click on Chapter 1, Getting Started, for instance, what you'll see here is a list of videos done by a professor at this college and some others I got from various locations that give you some other help, because I think the biggest handicap you lot are going to have, because it's asynchronous, is that you aren't always going to be able to have me and a person to ask questions to. So you could go here and say, oh, I'd like to do some types of data stuff, or I'd like to do nominal and ordinal. For instance, that's what we've just done right now, right? And they might tell you other things as well, and that's fine. It's good to know more than you need. And it gives you some help on this particular one, is all to do with Chapter 1. So anything in Chapter 1, here is a video. If we move down to here, you'll be able to get PowerPoint representation or
The
presentation.
screen is like black. I can't see it.
I will try
There we go.
out and in again. There. Are you looking at it now?
Yes, there we go.
Okay. So here are the videos I was talking about. Here is the PowerPoints, you know. They go over and they hit the key points. So they may phrase it in a better way that makes more sense to you, and I'm cool with that. And I don't know if you're going to see this one now. Is it black again, or can you see notes?
No, I can see the notes now.
Okay, so here are the notes that you can go through. And so I'm trying to give you as many resources as you can so that you don't feel like there's nothing out there to help me. I'm stuck and I don't know what to do. So that would be my first go-to place, would be Canvas, right? Inside WebAssign, which we'll do later, you'll find that they have an ebook, but they also have things like, you know, give me an example, show me some help, and things like that in various questions. So that's helpful. So I'm now going to go back to home. Can you see home, the Canvas general front page? Or is
Yep.
it black? Okay. If you need help with WebAssign, here you go. Click on them. We have a code for this class. The code is in there. I'll just read it out to you. You don't need to memorize it or anything because it's in the Canvas. It's Olympic 58716372. So this here just puts you through how you go about doing what you need to do. If I click on web assignment schedule, has it went black on you, or can you see that?
Still
I can
got
see
it.
it.
You can see it. Right, so what you can see here is, can you see what's going to be due week 1 and 2? Chapters 1 and 2. It's pretty cryptic. Week 3 and 4, chapter 3, 4. Week 5, there is no chapter 5, so it's chapter 6. And then your midterm. Now I can tell you about your midterm. Monday, 1 to 4. And it's going to cover the first half. So if you're wondering where you should be in the big scheme of things, this here will give you a very generic version of everything that's due and when it's due. So at the end of week 2, which to remind you is Sunday, October the 4th, this has to be done or else you won't get the points. I'll kick back out again. We still good? Can you see the, right. Now if you click on class Zoom schedule, boom. Here is the link to today's. If you want to see me again and just kind of come to my other stats class, it won't be continuous with yours because they'll be in a different place, but at least you'll get to see whatever I'm talking about, and this is a link to it. So you could just basically, you know, go at 1 o'clock on Friday and come in and see, because we'll be doing frequency diagrams and histograms on Friday. And if you click on this fella, you'll see some videos. So here are 2 videos. From that class already, right? So there's the first one that you didn't even know probably, but that was Monday and you just joined the class probably then. Here is their Wednesday class. I will be putting their Friday class here, and I'll also be putting this class, this one that we're doing right now here. So if you want to go and say, oh yeah, what was he talking about last week? I think I remember, but I need, you know, reminding. Then you could come here and just watch the video. And basically, all you do is, well, I'm going to try this. I've never tried this via Zoom. It probably won't work, but if you click on it, or double click it, so you see how it works? It's basically a video. There is a cool thing to do there. Did you notice I went and turned it up to high definition so that it's much clearer? Because it was a little bit blurred. And let's pause me. Actually, can you see that video, or did the thing go black on you again?
I could see it. That's very convenient. I like that.
What, the fact that I've got these videos for you?
Exactly.
Okay, so my job is to try and help you as much as you can. You're in my opinion, asynchronous classes are the hardest ones for students, because you can't always make the times that I'm doing my thing, and you know, you need as much help as you can. So basically,
yeah, thank you so much for that.
Not a problem. So this is, it's a long lecture, so you might want to do, I know, half an hour and have something to eat and watch a TV program, then do the other half hour, whatever suits your brain. But at least it's here.
You already know.
Okay. So I'll click that off, and there are tons of things, hopefully, tons of useful things on your site. So anything that I do a PDF of, any notes I make, anything that I physically do a Zoom lesson for, it will be in here somewhere. Specific to the class, things I haven't done, you'll find them in the chapter headings. But anything to do with Zoom, like the lessons today and one you saw, is in here. So one of these two, right, will have everything you want. Now, there's a guy down here called the TI emulator. You need a TI-84 for this class. It's mandatory. You can't do this class without a TI-84, or at least something as good as it. If you haven't got one, you can get a free borrowed one. You can borrow one for free, that's what I meant to say, from the Mesh office. You just phone up the Mesh office. Oh God, what's the number? It's on, you can find it on Olympic College the office for Mesh and talk to Cheryl, and she'll give you a calculator for the quarter, and it's free, and then you just return it. Or you can use this thing. This is kind of hit and miss. I use it. It's an emulator. Basically, it's a piece of software that you can do on your computer, and it emulates a calculator. So I'll show you what the guy looks like. It's kind of cool if it works. But as I say, it's hit and miss. I've had students, a lot of students said, yep, I got it to work. And just as many says, nope, couldn't get the thing to work. Don't know why. There it is. Can you see the calculator? Are you looking at it?
Yeah.
Right. Now, it's
Yeah.
just like a normal calculator. You click on the mouse, you switch it on. 7 times 9, and you press enter. Is that not cool? So
Very nice.
if you do have a TI-84, me personally, I love using the physical one because I don't know, it's maybe I'm old, but it's just better for me. But you know, it's a backup. It saves you having to, well, go through the hassle of getting a borrowed one, right? But if it works, you know, great. I guess you don't need to get a physical one. You'll be able to use the calculator in the test anyway, so it's valid. So I think that is me definitely covered most of that. I'm now going to see if I can return to page. Right. Now, the next bunch of stuff I'm going to help you with is not directly to do with my class. It's just basically to help you. Students in need group, they're getting some extra money. So if you have financial needs that is making it even more of a strain, contact them. They can help you. I don't know if they're going to be able to help you financially, but they could certainly, you can ask. I'm sure they won't have any problems with that. If you hit this link, it'll take you to all the technology resources. You can buy, I believe you can still, hopefully they've got some left over. You can do a borrower, right? You can borrow a computer, you can borrow a webcam. So if anything is broke, dies, Amazon said it's coming, but now I found out it's 2 months because it's still in China, right? You could contact them and see about getting a borrowed one. If you hit this fella here, it gives you a link to e-tutoring. And in e-tutoring, you can basically, you do a small Zoom lesson with someone who will help you with statistics. And there's a link to that same place. I don't know if that's worth it, but it's there anyway. It's an old link. Not sure how I have it there. And if you need to set up notifications, that's just a Canvas thing. So these are just basic financial resources. There's one that's not here, but it is mentioned in your syllabus. So if you click on syllabus, you'll see basically everything in one place, including when holidays are, you know, what's expected of you, the chapters we're doing, and it should be burned well here. And if it's not, I'm just going to tell you because I thought it was here. Okay, you need to, if you choose to, but I would suggest strongly you do it, to go and find the CARES grant site on OC and apply for one. They just opened up on Monday, and it's on a first come, first serve basis, and they've got $400,000 to give free money, so you don't pay it back. Basically, you just fill in an application, and if you get awarded it, depending on how many credits you're taking, it's $500, $1,000, or $1,500 that gets awarded. So if you haven't been given a CARES grant, then you go to the front of the queue. If you have already received it because of last time, it doesn't mean you won't get one. It just means you'll be lower down in the queue before they look for you. But they're not going to hang around long. So if you haven't done so, apply for the CARES grant. I can't emphasize that enough. I don't see why you should turn down, you know, $1,000 free dollars. I'm sure you could find lots of uses for it. They are so generic about what you can use it for. You can use it for food. Well, to me, that's pretty good, right? Because doesn't food count as a big chunk of what you spend all your money on anyway, right? So it's not like, oh, I can only use it to buy a textbook, or I could only use it to get my own TI-84, but you certainly could if you choose to do that. But you can use it for any life experience. You know, gas for my car, I guess, would count. My internet bill, like, that would count, right? So, okay, I've pushed it enough, but you get the gist of it. Apply for the CARES grant as soon as you can. Now I'm clicking over to WebAssign, so I'm pretty sure I have to go out and in to show you that one. And here is our class. And if I click on chapter 1, which is what we're on, we'll get that. Okay, I don't think you can see chapter 1 assignment. Is that true? Can you see it? It says questions 1 to 22 if you can. A yes or no would be cool. Can you see it?
Yes.
Okay. Oh, God. I'm lucky. Okay. So if you've never done WebAssign, depends on the question what you get to do. A lot of these questions are going to be very easy to physically do. You just pick a box. So let me pick something on what we've just done, right? Question 6. It says, what is the average miles per gallon for the new hybrid small cars? Using Consumer Reports, a random sample of such vehicles gave an average of 35.7 miles per gallon. So you can imagine what they did. They got 20 hybrid cars and they found out what they were, right? And the average ended up being about 35.7. Is this variable, right? The miles per gallon that they do, right? This guy here. Is this qualitative or quantitative or both? Average miles per gallon, like 35.7, for instance. Qualitative or quantitative?
Quantitative?
Okay, correct. A little hesitant. Well, tell me why you decided that, because that is correct.
Well, I had to look back in my notes,
Okay,
honestly.
right. And your notes said it was a number, right?
Yes.
And if it's a number, a real number, it's quantitative.
Yes.
I can never, ever imagine in a situation where that third box is ever going to be ticked. So if you've got one, the other, or both, never pick both. Right. I don't know if we got try to find some other. Oh, here's one. Here's the nominal ordinal interval ratio question, right? So suppose you found the length of times to complete an exam. So you went to 50 students who just finished their stats exam and you wrote down, it took you 210 minutes, it took you 87 minutes, right? You wrote those all down. So that's your data, a whole list of how long someone took to do an exam. One of these 4 is correct. So I'm going to do the first one, then we'll talk about the second one. The length of time, right? It's a number. So I'm not going to use nominal or ordinal. So now I'm stuck with interval or ratio. And then I'd say to myself, would it make sense to say someone took twice as long to do an exam as someone else? And I would say, yeah, which is why I'm picking ratio. Okay. Now, what about the next one? Time of first class. So the class could start at 8 o'clock. Somebody else, their class starts at 10 o'clock. Somebody else, it starts at 1 p.m. Someone else, it starts at 2 p.m. Now, it is a number. So because it's a number, doesn't that make it one of these two things? And then I'm going to ask myself the double question. if a class starts at 2 p.m. and another class starts at 1 p.m., does it make sense to say that the second class starts twice as late as the other? And my answer to that is no, it doesn't make sense. So that's why that's an interval. This one, you lot are going to do, and it might mean you look at your notes, and that's fine. Courses are a course evaluation scale. So you take a course, and at the end, you just give a very primitive description. It was either a poor course, you didn't do good, didn't learn much out of it, acceptable, right, guess in the middle, or it was a good course. So the answers that you get back from everybody who took part was one of those 3 words, typically. So here's the question. Which one of those 4 is that data?
Professor, do we have to open our own assignment page? Because your sharing page is showing the course name.
So you can't see any of these questions?
No.
Okay, thank you. I thought I got a yes earlier. Here are the questions, right? That's the ones I've just
Okay.
finished in, right? So, course evaluation then. Poor, acceptable, or good. Which one of those 4 data types is that story? That's my question. Which one is it?
Is it ordinal?
I like your answer. Slightly hesitant again. Oh, the baby's joining and she agrees. Good. What is
I
ordinal?
forgot
Why
to
did you
mute,
choose?
sorry.
Say again. Why did you use that as the right? It is the right answer. Why did you pick it?
Because poor, acceptable, and good have an order to them.
Yeah, has an order, and it's not numbers, right?
Yeah.
That's it. Last one. You collect ages on students. Which one of the 4 is it? Like 42, 50, 77, 12, whatever.
Ratio?
Good. Wouldn't it make sense to say a 40-year-old person is twice as old as a 20-year-old person? And it wouldn't matter if you turned their ages into how many days they were alive or how many seconds they were alive, wouldn't they still be double each other? So that is exactly ratio. The vast majority of numbers are ratio data. The vast majority are. There are a few exceptions, but interval data is much rarer, right? Temperature, right, degrees Fahrenheit, that kind of story. The time on the clock, right, what time does a class start at would be another example. So if you were a betting person, you're probably going to be successful picking ratio more than you would be if you just randomly picked interval, just because of the frequency of each kind of data. I'm not doing the next one, but can you see the next one is the same kind of bunch of questions and then another bunch of questions. Are you beginning to see how the homework is not actually that, this particular homework isn't that onerous? Isn't it just read the story, pick a dot, read the story, pick a dot? Relatively quick to do if you are up on the different types of data and what they're called. Now, there are only 4, right, subgroups, so it's not a huge difference, a huge number, but you do have to know what they are. I'm going to close this off for a little while, and I'm going to stop this, and I'm going to share this fella, I think. Yes. Right. Hopefully you are watching the page again. Are you seeing number 1 introduction, Math 146 page? Is that the one we're all seeing?
Yes.
Cool. Okay, so statistics is a branch of data, a branch of mathematics that deals with information or data. We've talked about this. Now let's look at this step. You've collected the data, right? You've found out the ages of 50 students in your class. You found out whatever that numerical data was. Let's stick to numerical. Here are, these are the kind of things that might come from that. Suppose you have a question you like an answer to, like what percentage of Olympic College students are 15 to 20-year-olds or 41 and over, right? Suppose you wish to predict who will win the next presidential election. That's actually very relevant right now. Suppose you want to know if there's enough evidence to prove that a new drug reduces cholesterol. You see, the kinds of things that statistics deals with is answering these types of questions. I mean, for those who are in the medical field, you are throughout your medical career, it won't surprise me if at all, you will be given information where they say, hey guys, there is a better way to do something. There is a new pill that reduces blood pressure that's much more effective and has less side effects. Or there's a new procedure for doing a particular operation that has a bigger success rate than the old. You know, like keyhole surgery was a big advance over the other, rip the guy open and bend his rib cage open just so he could get to his heart. So you can imagine that as time in medicine progresses, there are going to be questions like, is this new pill better than the old? You can't just say it is, because that's not evidence. In fact, if you allowed that, wouldn't all pharmaceutical companies say that theirs is the best thing since sliced bread, right? Theirs is brilliant, their pill's much better than anybody else. The FDA have quite stringent rules about what medications are allowed in the American market, right? You can't just make a pill for reducing blood pressure and sell it to Walmart without going through the FDA, right? You all understand there's good reasons for that, right? But how do the FDA actually know that this new blood pressure pill is better than the old? Well, we're going to learn in this class how they do that. When you go on TV and they say, Joe Biden is going to win the next election based on some polls that they've done, or President Trump's going to win the next election based on their polls. Now, is that wishful thinking, or did they actually go out and collect information, data, right, and do statistical analysis on it and to come up with that? Well, they did, hopefully, and we'll show you in this class how they do that. And simple things like, what percentage of Olympic College students are in a certain age group? Well, you know, the college collects data on all of you. I'm trying to remember. I think there's a survey called the PACE survey, P-A-C-E. I think there's another one which I can't remember. Have any of you filled in the last year or so one of the Olympic College's survey things? Anybody want to volunteer that they have? I'm feeling lonely here again. I guess the answer might be you haven't. Hopefully you know someone who has. Bethany, have you taken one?
No, I've seen it like on my site and everything, but I haven't taken it yet, but they are.
Okay. So that's probably why I'm not getting an answer, because none of you have taken it. It's pretty common. So on these things, they just ask you things like maybe what age group you're in, and they ask you some things about what's your major. And what the college is trying to do there is to get a feel for what Olympic College students are. You know, what's their distribution like, what's their age, what are they interested in doing. Off the top of my head, can you imagine that we gave a particular survey to first-time students at Olympic College, and we suddenly realized that twice as many are majoring in engineering, right? That's what they eventually want to do when they leave this college, right? If they got that information early, wouldn't that be helpful to the college? Because then they could start thinking about offering more engineering classes for those students. Have you, probably the nursing people might be in this boat, have you ever had the problem where you had this one blinking chemistry, biology, whatever it is class to do, and it's like twice as many people want to get into it because, you know, there's only one professor teaching it and there's 70 people want to take it? You ever had that experience where you have to be very selective about your picking your courses at certain times so you don't spend a quarter, you know, treading water so that you can get that last physics class to get what you need? That happens because we haven't collected enough data to realize what the demand for a particular subject is, and they change from time. So let's suppose we had one of these questions like this. What do you want to do with it? Well, you have to collect information called data. Well, what we could do, suppose we wanted to know the one about the ages. Well, we could do what's called a census. A census is the name that we give in statistics, where you just ask everybody. Every single OC student gets sent a letter, or maybe we've already got it on our database, you know, because we know your date of birth. I'm assuming we know your date of birth anyway. I don't get to say that kind of data. And couldn't we get the information from there? If you get it and it's on everybody, it's called a census. Some information, you can't do that, right? Suppose you were interested in asking students how many credits they're going to take next quarter. Well, it would be very costly and time consuming to do a census. Right, send out a letter. Do you know how much letters cost? If you do that times 6,000, that's a lot of money. And then the letters have to come back and we have to pay somebody, you know, whatever it is, $15 an hour data person just to get the data that's from a letter and get it in or whatever. We're not going to do that. So what we might do is a sample. We might just pick, you know, 500 students, like the 500 who might do the PACE survey, and we collect the data that way. For instance, if you're going to ask who's going to win the next general election, if that's what you're interested in, the first thing is it's a prediction. It's not a guarantee. Aren't you asking people right now, or yesterday, who they're going to vote for? But you don't ask everybody in America who they're going to vote for. I guess that's called an election, right? So what you do instead is you just ask some people. It's very often called a poll. It's just the same word as a sample. It's just we use that word very often when it's to do with politics and you're collecting data. You just do a poll of 2,000 American adults who can vote, and they say who you're going to vote for. And if 49% say Biden and 47% say Trump, and you know the others say whoever's left, then you can put that on the TV and you can say, looks like Biden's going to win, or it looks like Trump is going to win. And the last one, the medical one, that's treated very differently than the others. If I'm predicting who's going to win the next election and I screw up, it's not a big deal, because isn't next week there's going to be another poll and it will have different numbers. But if I'm saying to people, yeah, this new drug medication is better than the old one, and it's, in fact, it's not that good, right? It doesn't do the same job. It's not as good as doing it. Then in a lot of ways, haven't I harmed someone, right? I could even be responsible indirectly for someone dying if they were seriously ill. So they take a lot of time and effort in checking, do new drugs work? We'll get into a lot of detail on that. So here is some more jargon word for you. When you collect data, numerical data specifically, but you can do it with other things, the people you asked are called individuals. Right. So 400 individuals just means you asked 400 people. The data that you get from the individual is called the variable. So I might go and ask 400 individuals, what's your age? Right. The people I asked were the individuals, the variable was their age. I might ask 2,000 teenagers how tall they are. Well, The teenagers are the individuals, and their height, how tall they are, is a variable. We call all the people, all the individuals that you could ask or you're interested in, the population. So if I was interested in the average height of Americans, then the population would be all Americans. If I was only interested in the average height of OC students, then the population, right, the people I would ask would only be people at OC. I don't care what the height of someone at New York is. I don't even care what the height of someone who goes to, you know, Seattle Tech is. Your population has to be a group of people that you're interested in finding something about. Take the voting one. It's a good example. The population to be able to ask, the people you should ask in who's going to win the next general election, is not every person in America. That is not the population. It's smaller than that. How would you describe the population in America that you should be asking, right? That people should ask to find out who's going to win the next election? Let's try Valeria. Valeria, you got an idea? You can't just ask everybody. There's a problem with that. Who do you think you should ask?
Shoot.
Not sure. Oh, let me phrase it a slightly way. Should you ask 2-year-olds who they're going to vote?
Oh, you should ask people who have, you know, the proper age to vote.
Right, that's what I'm getting at, right? It's not, maybe, bad question. I phrased it badly. You get what I'm getting at, right?
Yeah.
You can't ask 2-year-olds, right?
Right.
That's a pretty obvious one. So they have to be voting age, right? That would make sense. A little bit less obvious, there are other people you cannot ask. I'm actually one of them. That's got you puzzled. Why can't I vote?
People who aren't registered to vote or legally allowed to vote.
Correct. And I am not legally allowed to vote because I am a permanent resident. I am not an American citizen. So I am not allowed to vote. So the population would be something that's hard to phrase it well. I think the way you phrased it, Bethany, was probably quite good. I'm just going to paraphrase it. The population are people who are allowed to legally vote in America. That would be your population. Would that be the people you should ask? So don't ask me, because it doesn't matter who I said I was going to vote for. I'm no yes, because I can't vote. So do you see how populations can be, you know, are dependent on who you're going to be interested in asking that question to? And we go on and we basically cover that. Okay, so I'll close that off now. We're getting better. Or I'm getting better or something. I've lost you. Oh, here we are. Now, I'm going to go over some details about that whole process of who do you pick. So, you know, how do you choose samples and such like? So I'm going to move this thing over here. Right, you should be looking at my hands now wiggling up and down. Agreed?
Yes.
Good, okay. So, suppose you wanted to find out people's opinion on, oh, yeah, I like this because it's a very particular one. That's people's opinion on abortion. So you get a really good job, you work for CBS or Fox or some company like that, and they say, hey guys, we want to do an article next week. We want to do a little show on what Americans think about abortion, and I want you to go out there and do a poll find out what Americans think about it. So we're going to look at how this process from start to finish might work. So I think the first question I should be asking myself is, who should the population be? Well, again, it's kind of like the polling one. I don't really want to ask 3-year-olds their opinion of abortion. You agree that's silly. I probably don't want to ask 12-year-olds. They're probably a little bit too young to be, what's the word I'm looking for? To have a fixed opinion of it. So let's say I just decide, and it's kind of arbitrary, that I'm only going to ask adults, and I'm describing adults as 18 plus. So I've decided that when I do this one, this is adults 18 or over opinion of abortion, right? So that's basically that part done. Are you comfortable with my choice, or would you tweak that choice? Would you say maybe 16 plus would work for you? You think 16-year-olds are mature enough to make a good decision on that particular question? 18, 16, we cool? Any issues? Okay. Now I have to decide a census or a sample. The decision is pretty easy. CBS or Fox are not going to give me $50 million because it probably cost me that to do a census. In other words, to ask everybody. So I'm going to opt for a sample, right? Would that seem reasonable in this story? They're not going to give me enough money to ask every single American, what's your opinion? So I'm going to have to pick a sample. So now my decision what kind of sample? What do I mean by that? Now, let's be silly. Could I, because I'm a lazy guy and I don't want to work, could I just get 10 people who happen to live in New York? So I walk out CBS's building, I think it's in New York anyway. I walk outside their building, I have a little, clipboard in front of me, and the first 10 people that come by, I say, what's your opinion of abortion? And I write down their answer. And then I come back to my boss and say, I've got the answer for you. And do you think that would be a great sample? Valeria, are you talking? Because your yellow band is in it, but I can't hear you. You have to hit the space bar if you want to say something. Is anybody else here? I'm feeling lonely again.
I'm here.
Yay, Courtney's here. Anybody else here?
I'm still here as well. My house just gets kind of loud sometimes. We have quite a few dogs and cats, so
I gotcha. Hey, don't
turn on the
worry.
mic a lot.
I'd rather hear your answer and dogs and cats barking than not. So don't worry about it if that's going on. So I definitely have two of you. Valeria, are you here then?
Yeah, I'm here.
Oh, good, good. Okay, now, I was saying what kind of sample. What I'm talking about here is a couple of things. The first thing is I need to have a sample size. It's a good idea to have about 1,000 people in your sample. Anything smaller tends to be fraught with just randomness. You could just get a bad group of people, right? Can you imagine if I asked 10 people, I could get 10 pro-abortion people or 10 pro-life people, right? I could get whatever it is, right? So size is important. Make it, for want of a better word, make it big. As big as you can afford. So, oops, we've done that. 4. I've got my sample. It's 1,000 people. And I want it to be 1,000 and what's called a random sample. Now, what does that mean? Right. I can't just pick 1,000 people from New York. I can't pick 1,000 people who just live in Texas. Isn't the opinion of abortion probably not the same in every place in America? Aren't some places, Utah, going to be more one way and New York more the other way? Can you imagine that is a relatively likely event? So what does a random sample do? Basically, you spread out your people that you ask so that they come from every state in America, all over the place, right? So there's New Yorkers in there, there's people from little towns in the Midwest, there's people from big cities on the West Coast, there's people from Houston, there's people from Dallas, right? There's people everywhere. So a 1,000 random sample. How do you ask the question? What on earth am I getting at? Right, you're going to have a guy with a clipboard, or you send out a letter, or whatever way you phone them up, but you've got to ask them the question. And to be fair, shouldn't you ask the question with the exact same words in the exact same way to everybody, right? You want them all to be asked the same question, right? For comparison reasons, that makes sense to us. So you might think, well, how am I going to do that? Well, there's a couple of ways. One of them would be, are you in favour of abortion? And then you give them a scale from 1, 2, 3, 4, 5. And on 5, you're very much in favour of it. Here you're in favour of it. Here you're kind of on the fence. Here you're against it. And here you're very against it. You know, the usual kind of from 1 to 5 scale. And if I phrased the question, are you in favour of abortion? Couldn't you get one of these 5 numbers from each of your people, and that's how you would get your data on are you in favour of it? You could say, are you in favour of it? 1 was yes, 2 was no. Can I ask the question in that way? What's the problem? Or can you see any problem with just giving a person a yes/no choice on something that's as important as about your opinion of abortion? Now, don't answer this question. I'll phrase it like this. If I went and said to you, are you in favour of abortion or not? Would you find it difficult to say yes or no to that question? I don't want you, just say it to yourself, don't advertise it, because I don't need to know that. But do you see it would be quite a difficult question? Because aren't some questions not as clear cut, isn't there? Well, yeah, I can see this point of view, but I also see that point of view. I'm more in favour of this idea, but I'm not 100% anything, right? And in many big decisions, there is a lot of grey area in that. So I would probably suggest not to do that one, and at least give people a little bit more leeway, right, a scale, to do it. Of course, I'm about to, keep putting this as a warning, I'm about to offend at least half of you, if not more. And I'm not doing it to offend you, I'm just doing it to give you an example of bad questions. Are you in favour of abortion might be considered, and hopefully it is, as not too provocative a way of asking it. But suppose I phrased the question in one of 2 ways, so this is how you're going to get offended. The first way I could have said, are you in favour of a woman's right to choose to have an abortion if she's already consulted with her doctor and it's considered the best thing for her? Is there a problem with the way I phrased that question? Do you know, if you're against abortion, wouldn't that offend you? Wouldn't that be That's a very biased way of asking it. Would you agree it's biased? It's biased in the sense that it's more likely to make you want to be in favour of this. Well, I'll try the other one. Maybe that'll offend you more. Not again that I'm trying to offend you. Suppose we ask the question like this. Are you in favour of a woman killing her unborn baby just because she wants to? That should get you going, shouldn't it? Can you see that you shouldn't ask a question in a biased way? A way that will offend people or try and influence people. And it's quite dangerous, and it's very subtle how politicians can do that. They won't be as blatantly bad as I was, and I apologise again if I did offend any of you with the phrasing of those two questions. But can you see the problem is that if you phrase something in a particular way, can't you influence the answer? Gary Young, have you, yeah, Valerie, you got any opinions on, did you think both those were equally bad, or was I worse on one and still bad but not as bad on the other? Or were they equally bad in your mind? You want to share any comments with that?
Did you say my name?
Yes, sorry Valerie, yes.
Yeah, the way you phrase the question kind of sets them up to like feel obligated to answer in a certain way.
Yes. Now, I think if you were being asked on a mall or a question that was phrased that way, I think you would recognise that they were trying to influence you, and that is safe. But what's less obvious is that there is subtle ways in which people can, politicians especially, can phrase their questions. And that's why you can have two totally different polls on abortion. And one of them says the majority of Americans are in favour of it, and the other says that the majority of Americans are against it. And you might say, well, how can it be true in both situations? Well, you'd have to look, because they never tell you, really, how they phrased the question. Now, you don't need to be over the top as I did, but couldn't you phrase it just by the way that you describe it? Do you know that they don't say abortion or not abortion? Aren't they, oh God, I've almost forgot the phrase. Don't they tend to go by the women's choice and, oh, something to do with life. I've forgotten what the one with the word life in it. So both parties tend to describe their viewpoint by using a term that is positive for their viewpoint. And so when they do opinion polls, those two things tend to generate different answers. That's why you can have the same basic question with two different answers. Here's an example. If I went and said to you, are you in favour of the government spending more money on the homeless? A lot of people would say, yes, I think that's a good idea. Homeless people need more money, to help them. If I went and said to you, are you in favour of paying higher taxes so that we can spend more money on the homeless? Do you see that that second answer might not get the same percentage in favour of it as the first one? People like nice things, but at the same time, not everyone likes to pay for them. And if you give them two different ways of phrasing something, you can influence them. It's a common feature that one of the biggest problems with collecting data is very often right here. Because if you screw this up, it really doesn't matter what happens. Your data is already corrupted, right? Any conclusions that you get are pretty much biased. And biased conclusions aren't really any good for anyone. You might as well just save a lot of money and just say 55% are in favour of whatever it is you're in favour of. And just not bother doing the whole survey at all. And then the last step. Let's suppose you did it really well. You got a good unbiased question, you asked it in the right way, you get to stage 5. What does stage 5 is? Well, you've collected the data and you analyse it. And there's a lot of cool stuff that's going to happen in that, but not right now. Any questions about the general process of how you collect information, which is basically this 5-stage process? Last question? Any questions? Okay. Now we're going to look at, this is the last part of chapter 1. We're going to look at experiment against observation. So this is a particular type of situation where you're collecting information, data, and you're trying to, from that, come up with some conclusions about what's going on. So an observation, what makes an observation an observation is basically this: you have no control over anything. That's pretty bad. So what would an observation look like? An observational, very often is called an observational study. Give an example. Psychologists are interested in the behavior of small children, and in particular they want to see is there any difference in the propensity of violence amongst boys and girls. So what they do is they just set up a camera with the parents' permissions inside the play area where the kids go and play, you know, maybe during breaks or whatever. And a guy with a little clipboard videos it, and he records interactions between the children, and he records how many times one little boy hits another little boy, and how many times one little girl hits another little girl, and how many times a boy hits a girl or a girl hits a boy, right? So you can imagine he's saying, okay, George hit Peter, Peter hit Mary, Mary hit Mary's pal, and so on, and they collect that data. And let's just pretend that little boy hit another little boy happens 15 times. Little girl happens twice, and a boy-girl or girl-boy interaction involving, you know, it doesn't need to be a hard hit, happens once. They would this is observational. Why? Aren't they just watching? They're observing. They're having no control over the situation. They're just looking. Now they have a conclusion. If this was real data, wouldn't you be able to write a little report, a little psychology report, and says, from our studies, our observational studies, we've concluded that little boys are more violent than little girls. And our evidence for that is that little boys hit other little boys much more often than little girls hit little girls. Do you see how that might be a valid conclusion based on a very small observation? So you see how observational studies work. Let's take one in the medical field. I tried this with my other class. Maybe I'll work better with this one. In Britain, and I'm sure in America, there was a pill. In Britain, it was called thalidomide. But the Americans may have had another name for it, a generic name for it. It was a pill given to pregnant women to reduce morning sickness, right? So it wasn't really a high up, heavy duty, you know, high profile thing. It was a bit like taking aspirin, right? But they took it, and what they discovered was over the years, doctors were noticing more and more mothers were giving birth to children where their limbs weren't fully developed. Very often their arms weren't developed, but sometimes their legs as well. And they were wondering what the heck was going on. And so they went back and they looked at their data of pregnant mothers that had given birth to children like this, and they looked at the medication, and they looked at their lifestyle, and they looked at where they lived in case it was something in their diet. They looked at, you know, what the air was like. They looked at tons and tons of things, and they came across one kind of, for most of them, because, do you know, before this thalidomide drug was even around, mothers occasionally still had babies with this deformity, right? It just happens in nature as well. But the overwhelming majority had taken this pill, thalidomide. And that's how they discovered that thalidomide was causing it. Now, it's an observation. They say that actually they didn't even know that they had to observe it until doctors saying, you know, I see like this once every 5 years. You know, a mother that gave birth to this, and all, you know, we're talking about doctors who deal with births, right? What's the maternity doctors? That's not what you call in America. What do you call a doctor who helps with the birth of a child? There's one nurse amongst you. Come on, what do you call you? Okay, you're a maternity doctor then. So they discovered then that they were getting much more of these births than ever before. And that's what set them off, and they did an observational study. And they discovered thalidomide and stopped the production, and then there was court cases ensuing and so on after that. So what does an experiment look like? Well, in an experiment, you have, for the most part, full control over, oh, I got a question. Oops, question disappeared. Whoever just did the question, if you ask me, I can't really see your text messages because of the way my system works. Right, in the experiment, they have full control of everything. So what would an experiment look like? Here's a good example. You've got a new drug. Does this new drug, is it better at reducing your blood pressure than any of the drugs they've got today on the market? So the FDA will say to you, right, you've got to prove it to us. How are you going to do that? Well, they get 1,000 volunteers who have blood pressure issues, and they typically split them into 2 groups, let's say 500 in each, and they do that split totally randomly, right? So they just get a computer and say, you're going into this group, you're going into that group. They don't tell anybody what is specifically the group they're in, because there's 2 groups. There's a control group, and the other one's called the experimental group. And typically, the people who take part in this drug trial do not know which one they're in. The control group either get one of 2 things. It depends on the situation. They either get the old drug, right, the blood pressure drug, or they get a thing called a placebo. And the other group, they get the new drug. Has anybody heard of the term placebo?
Yes.
Yes,
Yeah.
Valerie?
Yes.
Mason? You've heard of it?
Yes. Yes.
Right. Is that from the nursing program or just in general life?
Just in general.
Right. So essentially what a placebo is, it's a non-effective drug. It's basically a sugar pill. And you give it to people so that they're getting a pill, and you disguise it so that you can't tell the difference between that pill and the new drug. In fact, if you've been really good about it, you make them the same color and the same shape. So as far as you're concerned, you are getting the blood pressure drug, for instance, or whatever it might be. And the reason they do that is because they found a thing called the placebo effect. And what that meant is if you gave someone a pill and they believed that pill was going to do some benefit to them, even although the pill had no active ingredients in it, it would actually help them. It depends on what you were doing it for. So if it was something subjective, like I have a headache and I need a pill to make my headache, less severe or even make it go away, it's very good in those situations, because in those situations, because pain is very subjective, your brain is basically deciding what level of pain you're getting for the most part, especially in things like headaches. If you believe that the drug works, your headache will go away or at least reduce. And there's nothing in it except you've convinced your brain that things are okay and I'm taking something for it and you don't need to make me hurt so much. And so that's what they did here, and they have a placebo of the old drug. And then you collect, I don't know, once the medical trial is finished, and it could be anything, right? Let's say it was 10 weeks. Sometimes it's 10 months, sometimes it's 10 days, but whatever it is, 10 weeks later, you collect the data. Now, if the new drug is better than the old drug, won't there be a better percentage success rate here than there? So the new drug reduced the blood pressure on average by 12%. The old drug only done it by 10. In that case, then you've got evidence that the new drug does better than the old. And you could present that information to the FDA. The FDA want you to do this as well. When you do this, if it's at all possible, it needs to be a double-blind experiment. Courtney, have you ever heard of double-blind experiment? Gary Young, have you heard of it?
No.
Oh, okay. That's a valid answer. Bethany, have you heard of it?
Yes, I have.
Do you know roughly what it is, or you've only heard the term but you're not sure what it means?
A double-blind experiment is when the patient and the person giving the placebo or the new drug, they both have no idea which is which. So they're conducting experiments with no knowledge at all.
Perfect. Said it better than I would have. Yeah, that's exactly what it is. And that makes the data very good. If you don't know you're getting the pill, the placebo or the good drug, if the doctor, because very often you're in your own doctor as the person who's checking your blood pressure and doing all the good stuff, he doesn't know what you're getting. Now, you put those two things together, what you're looking at there then is very good data, and the FDA will look at that and give you a clean bill of health. Now, there's lots of other parts of this that are not here. And before you even get to this, because this is stage 3 really, they have a few other stages. You know, one of the first stages is a very simple one. You have a very small trial. You're not interested in the effectiveness actually at this stage, although you collect that data. You're just checking on safety. So you get volunteers and they take, the drug, and if suddenly people are dropping dead with heart attacks or having aneurysms, you say, okay, we're pulling that drug right now. It ain't going to work for nobody. Even if it reduces the blood pressure of everybody that it doesn't kill, it's probably not a good drug if it kills some people, right? You would think. Although, I'm going to change my mind on that. Have you ever seen TV programs where they advertise drugs? And it could be anything. It could be a drug for diabetes or a drug for asthma or whatever it is. And then at the end, they scare you, because they give a big litany of all the things that might happen to you if you take this drug. And I'm making these up, but it goes like, has been known to cause heart attacks, brain aneurysms, and sudden death. And I'm thinking, I'm not so sure I want to take that drug now. And I think they put that in to cover themselves legally. Because all that could mean is that one person who took that drug died of a heart attack, or 2 people who took that drug got an aneurysm, and there might be 100,000 people taking that drug every single day, and there's this small, very unfortunate group of people that had terrible side effects, and that's why it's there. So they're saying, look, if you take this drug, this could happen to you. So if you choose to take this drug, it's like signing a waiver, right? If I take a heart attack and die, it ain't my fault. I wonder if that's why they do that. On a closing note, because we are at the end of our time, taking drugs for any medical purpose is always fraught with danger. I can't imagine any drug in the world that won't kill someone. And you might think, oh no, that can't be true. I'll give you an example. Are nuts poisonous? Are they dangerous? Well, the answer is yes. Aren't there some people, if they eat nuts, will die? Should we ban nuts because some people die? I have a sister, my sister Lillian, who is allergic to any drug that has sulfur in it, right? She has an allergy to sulfates, which means that I believe quite a few antibiotics are bad for her. She might even die if she got them. Should we ban all antibiotics because my sister is allergic to them? Do you see the problem with new drugs is, yes, some people will die of them. I bet you there's somebody in America who will die if they get an aspirin. They just don't know it yet because they've never taken one. But can you imagine their body chemistry is just weird, and an aspirin could kill you? So every single drug is going to have bad side effects for a very small group of people. And so what you have to do is you have to balance the benefits against the side effects. Antibiotics save more people's lives than my sister who's allergic to them could die of them. Can you see why antibiotics should be used then? We're coming up in the COVID vaccine. I'm making a prediction here. See when it finally comes online, somebody's going to get that vaccine and die of it. I mean, they're going to have an allergic reaction and they're going to die. That's guaranteed. And when that happens, because it will happen, isn't it going to be on every news station in America? And do you know, if we're not careful, what that will do? A lot of people will not get the vaccination, right, because it scared them. And those people who don't get that vaccination, do you know, more of them are going to die of COVID-19 when they get it than would ever die of the vaccination. So you have to have benefit and effect and look at them. So that's my prediction. See, when it does happen, can I get kudos is the wrong word because I don't want anybody to die. But will you at least remember what I just said there and think seriously about taking the vaccine, whatever that vaccine ends up being, and whenever it does eventually become online. But you all make your own decisions, and that's important.